Alright, so now we're going to look at how we use what we just learned in the last video into making what we call an orbital notation. We're going to use the same F-bow chart that we did before when we did the electron configuration. And this is just another way, again, to show how those electrons are configured in the atom. So let's just choose a random element. Looking at the periodic table, the first element I looked at was magnesium. So how would the orbitals look when we put all the electrons that magnesium has in them? So to find out how many electrons magnesium has, we first look to the periodic table, find atomic number for magnesium, and this is going to give us 12 electrons. Now, using our electron configuration, we're going to see that the first place that we find an electron is in our 1s sublevel. And if we remember from the previous video, an s sublevel looks like one orbital. And in that, we have two arrows. And since we have two arrows in an orbital, they have to be pointing in opposite directions. They have to have opposite spins. So this is just another way of saying 1s2. Nothing different there. So after 1s2, we go down to 2s, and an s sublevel, regardless if it's a 1s, a 2s, 3s, is just one box, and we're going to put two arrows in there. Remember, we're trying to add up to 12 electrons. After we get to 2s, then we follow the next arrow down. We start off with 2p. And from the last video, a p sublevel. It consists of 3 orbitals. So this is going to be 2p. And we have enough electrons to fit 6 in there. And notice how I'm filling this. I put an up arrow in each of those boxes first before I went back and put the other electrons in there. The way I think of this, imagine this as a movie theater. And instead of single seats, they've got love seats there. If you're going alone, you're probably not going to sit next to some strangers, so you want to spread yourselves out as best they can, and then only double up if you have to, if there's no more room. So that's our rule with filling our orbitals. If there's enough electrons for at least one in every orbital, you'll spread them out first, and then double up with any extras that you need. And we'll do some examples that have that kind of more pronounced there. So now we've got 10 of our 12 electrons accounted for. After 2p, then we go to 3s. And we can fit 2 electrons in an s sublevel, and we have 2 electrons to give, so this would be the electron configuration for magnesium. All right, let's go look at another example. Let's say, for instance, sulfur. So sulfur has 16 electrons, so it's going to look just like the magnesium for the first 12 of them. So an up and a down, we'll call that 1s. Another box with an up and a down, we'll call that 2s. And then 2p with an up, 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 down, down, down. And then we go to 3s with an up arrow and a down arrow. That's not meant to look like a superscript. It just would look just like that. That's not meant to be as mangled as that is, but oh well. And then after 3s, we go to 2p. Now we need 16 electrons. Right now we've got 12. So we only need 4 in our p, our 2p sublevel. So the way we're going to fill these is we're going to put 1 electron in each of these. Remember, spreading them out as best we can. And then now to put our 4th one in, we'll just come back and then put a down arrow in the first orbital of our p sublevel. And that's how you do these. The only difference with bigger or smaller elements is you'd continue going on to p and s and d and f, and d sublevel, instead of being 3 boxes, 3 orbitals, would be 5 orbitals. And an f, instead of being 5 or 3 orbitals, would be 7 orbitals. The other way we could do this, like we said, was with lines. So this would look like this. I'm breaking my rule there. Bad habit. It would look like that. Now suppose we only had 2 electrons in our p sublevel. That means we wouldn't have anything in this 3rd orbital. We would still write it. So you can have empty orbitals, we'd still write them. Alright, that's it.